Okay, friends, after knowing the meaning and definition of the nozzle and also applications of steam nozzles and types of nozzles, now we have to go through the new topic, that is flow through steam nozzles. The, in this particular topic, how the flow will be taken place across the surface of the steam nozzles, how it will be in convergent part, in throat and divergent part. Steam enters the nozzle with a relatively small velocity and at high initial pressure. The initial velocity is so small compared to exit velocity that it may be neglected. Flow of steam through a nozzle is regarded as adiabatic. As steam expands, its velocity increases. The heat energy of the steam is converted into kinetic energy. Work is done by the increasing the kinetic energy of the steam. At the end of expansion, the pressure drop results in the enthalpy drop. Hence, change in total heat of steam must be equal to increase in kinetic energy. As we know that the steam, whatever steam, the working fluid is there, that will be passed through this convergent part, and through throat that will be coming out to divergent part. As it low pressure high pressure steam that will be enters to the convergent part, it will be get expanded, where its velocity will be decreased in velocity will be low in convergent part, and as it enters into throat it becomes a sonic region where the velocity will be increased as compared to in convergent part, then it will be increased to divergent part. It means the divergent part having the higher velocity as compared to convergent part. So there are basically three types of flows are there. The first one is the frictionless adiabatic flow, and second one frictional adiabatic flow, and third one supersaturated flow. In this particular first frictionless adiabatic flow, as there is no friction between the working fluid and the surface of the nozzle, it taken place completely frictionless. That's why this is called as a frictionless adiabatic flow. The second one, frictional adiabatic flow, it takes into account the friction produced between the walls of the surface of the nozzle and mass of the system or working fluid. This friction causes resistance to flow, which is converted into heat. Steam at the expansion tends to the condense, but heat produced by the friction tends to dry it, thus improving the dryness fraction at a exit pressure. Means the friction that causes results to resistance to flow, which is converted into heat. So whatever the resistance is there, that will be converted into heat. So this heat, which will be what affecting the quality of the steam. The quality of steam is nothing but dryness fraction, due to which the it improving the dryness fraction of the steam. And third one is supersaturated flow. This type of flow occurs in a divergent portion of the convergent divergent nozzle. When steam passes through nozzle, the velocity increases, and further expansion in divergent portion takes place very rapidly. Due to rapid expansion, the steam does not have time to condense. It remains unnatural, dry or superheated state. So this is about flow through steam nozzles. The next topic is shape of the nozzle. The shape of the nozzle is a very important topic regarding the steam nozzles, which is depends upon the velocity of the fluid that flowing through nozzle and Mach number of the fluid. Before going to deal with these parameters, first we have to understand what is this Mach number. The Mach number will be defined as the ratio of fluid velocity to velocity of the sound, that is given by m equal to v by c, where v is the fluid velocity and c is the velocity of sound. The figure shows that three different sections of nozzles. It means that will be indicating convergent part, throat and divergent part. The convergent part in which the velocity is very low, which will be indicates subsonic region, where the Mach number is less than 1, means fluid velocity is less than velocity of sound. As the fluid it will enters into throat from convergent part. It becomes sonic region, means the Mach number is equal to 1. That is, fluid velocity is equal to velocity of sound. As this will be now enters into divergent part, where the all the all heat energy is converted into kinetic energy, due to which the velocity will be rapidly increased, in which the uh, in which the fluid velocity is greater than velocity of sound, it means Mach number is greater than 1. So these are all the things through which we can conclude for the shapes of the nozzle. So which is a very important aspect of this steam nozzle. In the next topic we have to deal with an important derivation regarding the velocity of steam at the exit of the nozzle.